Good morning, myself Charan. Today in this video, I would like to share the topic regarding real numbers. Okay, what are real numbers? A real number is a combination of both rational numbers and irrational numbers. Then what are rational numbers? A number which can be written in the form of p by q or fractional format are called rational numbers. For example, 0.5. I can write 0.5 in terms of fraction as 1 by 2. Okay, what are irrational numbers? Irrational numbers are the numbers which cannot be written in the form of p by q or fractional format, right? So examples for irrational numbers are pi, root 2, 0.1222, so on. Okay. In this chapter, we mainly focus on two important properties of positive integers. They are namely Euclid's division algorithm and second, the fundamental theorem of arithmetic, right? Euclid's division algorithm. This Euclid's division algorithm states that when any positive integer a can be divided by another positive integer b, then the remainder r, which will obtain in the division process, is always less than the divisor b. That is, the range of r always lies between 0 less than or equal to r less than b. Okay. The general equation of Euclid's division algorithm is a is equal to bq plus r, where a and b are natural numbers and q is coefficient and r is remainder. Okay. Now we mainly use this Euclid's division algorithm for finding HCF of two or more numbers. Okay. Let us see 2-3 examples to understand the concept better. First example, use this algorithm to find the HCF of 4052 and 12576. Okay. Before finding HCF, what you have to do? We have to identify which is a larger number in the given numbers. Okay. From these two numbers, I can easily find that 12,576 is a larger number when compared to 4,052. So I want to write this larger number in terms of smaller number into coefficient plus remainder. That is, I can write 12,576 in terms of 4,052 as 12,576 is equal to 4,052 into 3 plus 420. Again, 4,052 can be written in terms of 420 as 4,052 is equal to 420 into 9 plus 272. Again, 420 can be written in terms of 272 as 420 is equal to 272 into 1 plus 148. Again, 272 can be written in terms of 148 as 272 is equal to 148 into 1 plus 124. Again, 148 can be written in terms of 124 as 148 is equal to 124 into 1 plus 24. Again, 124 can be written in terms of 24 as 124 is equal to 24 into 5 plus 4. Again, 24 can be written in terms of 4 as 24 is equal to 6 into 4 plus 0. In the last step, we find that the remainder becomes 0. That indicates that this is the last step of doing the division process. Now, we have to compare this equation with the general equation of Euclid's division algorithm, that is a is equal to b into q plus r. Here the value of a is equal to 24 and the value of b is equal to 4 and q is equal to 6 and remainder r is equal to 0. Now when r becomes 0, then the value of b becomes the HCF of the given numbers. That is, here in this equation the value of b is equal to 4, so the 4 becomes HCF of the given two numbers, that is 4052 and 12,576. Okay. Here there is a note that the 4 is not only the HCF for the two numbers 4052 and 12,576. It is the HCF for all the a and b values in each and every step. That is, 4 is equal to HCF of 24, 4 and HCF of 124, 24 and HCF of 148, 124 and the HCF of 272, 148 and the HCF of 420 comma 272 and the HCF of 4052 comma 420 and the HCF of 12576 and 4052. Okay. Example 2. Show that every positive even integer is of the form 2q and that every positive odd integer is of the form 2q plus 1 where q is some integer. Okay. We know that the general equation of useless division algorithm is a is equal to bq plus r where the range of r lies between 0 less than or equal to r less than b. Okay. Let us assume that a be a positive integer and the value of b is equal to 2. When you substitute the value of b is equal to 2 in this general equation, we get a is equal to 2q plus r where the range of r lies between 0 less than or equal to r less than 2. That is, the value of r is equal to r equal to 0 and r equal to 1. Okay. If you substitute r equal to 0 in this above equation, we get a is equal to 2q, and if you substitute r equal to 1 in the above equation, we get a is equal to 2q plus 1. So that indicates a is equal to 2q for every positive even integer, or a is equal to 2q plus 1 for positive odd integer. Okay. Example 3. Show that any positive odd integer is of the form 4q plus 1 or 4q plus 3 where q is some integer. Okay. We know that the general equation of useless division algorithm is a is equal to bq plus r where the range of r lies between 0 less than or equal to r less than b. Okay. Let us consider a be any positive odd integer and the value of b is equal to 4. When you substitute b is equal to 4 in the general equation, we get a is equal to 4 into q plus r where the range of r lies between 0 less than or equal to r less than 4. That is, the value of r is r equal to 0, r equal to 1, r equal to 2 and r equal to 3. Okay. If you substitute r equal to 0 in the above equation, we get a is equal to 4q. If you substitute r equal to 1 in the above equation, we get a is equal to 4q plus 1. If you substitute r equal to 2 in the above equation, we get a is equal to 4q plus 2. If you substitute r equal to 3 in the above equation, we get a is equal to 4q plus 3. So, it is a mixture of even and odd terms. But in the question, what they are asking, show that any positive odd integer is in the form. So, if you want to get odd integers from this, we have to separate the positive integers from odd integers. So, here I can consider a is equal to 4q and a is equal to 4q plus 2 as a positive odd integer, even integers. Why? Because these two terms can be divisible by 2. Hence, the remaining terms a is equal to 4q plus 1 and 4q plus 3 are the positive odd integers which are in the form of 4q plus 1 and 4q plus 3. Right? Example 4. A sweet seller has 420 kaju burfis and 130 badam burfis. She wants to stack them in such a way that each stack has the same number and they have to take the least area of the tray. Okay. What is the number that can be placed in each stack for this purpose? Okay. For this type of problems, what we have to do? We have to find the HCF for the two given numbers, that is 420 and 130. Okay. Before starting HCF, first step what you have to do? We have to identify which is the larger number among the given numbers. I can clearly say that 420 is the larger number when compared to 130. So, I can write 420 in terms of 130 as 420 is equal to 130 into 3 plus 30. I can write 130 in terms of 30 as 130 is equal to 30 into 4 plus 10. I can write 30 in terms of 10 as 30 is equal to 10 into 3 plus 0. In this step, I found that the remainder equal to 0. That indicates this is the last step in the division process, and the divisor which was present in this last step is called the HCF of the given two numbers, that is 420 and 130. Hence, the number that can be placed in each stack for becoming the same number of stacks and also for occupying the least area of the tray is 10.